Thank you, Steve. Please continue with your meeting.
Very good. I'm going to post the agenda in the chat window. It's pretty short and sweet today. Let me share. Pretty short and sweet today. So the only update from me is that CycloneDX 1.6 was released on Tuesday. So yay. Really excited about that. A lot of you on the TC have contributed to that. So thank you very, very much for your contributions. 1.6 wouldn't have been a success without your contribution. So thank you very much for that. And other than that, we're going to continue reviewing the draft of the specification, which is the human readable part that we're working on. Again, just a reminder, we are going by the not necessarily by the page number or by the section number, but essentially the breadcrumb, the location of kind of where something resides in the specification. And last time we left off while discussing the manufacturer. So let's continue where we left off there. Okay, so the manufacturer does have an address. This is a physical address to the location. Again, the BOM ref, which is an identifier that is unique within the bill of material itself, identifies this particular address. You have the country, region, locality, post office box number, postal code, and street address. All of this is aligned with the specifications over at schema.org. So this is not recreating the wheel. This is already kind of part of the schema.org spec. Let's see. This is just the description of these particular fields. They're pretty much all optional. The country code is the ISO 3166 code. Region is a string. Looks like with the examples, it's probably Matt contributed this. So locality or city, post office box number, postal code. All these are strings, obviously. Street address, organization URLs. So 0 or more URLs to the organization itself. And then, of course, this must be a URL, an international URL that's specified in this RFC. The contact. Now, all of the contacts throughout the spec also, just like the organization, all of the contacts that describe like an individual, they're all going to have the exact same information. We do not duplicate this information. It's essentially a reuse of the exact same model. So this is the first time that we're encountering this, I believe. So we'll kind of go through it this time, and then we will go through it a little quicker in subsequent times, because it's going to be the exact same data. Again, the contact does have an identity. So in this case, it's the BOM ref. The name of the contact, which is a string, email, phone. So this is the BOM ref again, string with a description of what that is. We've got the name of the contact, the email address. Again, this is an international email address defined in this RFC. Phone number. This is going to be the authors. Now, this is the authors of the BOM. A lot of BOMs may not necessarily have authors. A lot of BOMs will be created by tools or through automated processes. However, in some cases, especially with maybe languages or ecosystems that may not necessarily have the automation in place, or maybe it was done through some kind of reverse engineering, whatever the case is. In some cases, you might actually have humans, authors, that have actually created the BOM, and that's what this field is. Again, this is the exact same fields that we just talked about just on that previous thing, where we've got a BOM ref for the author, the name of the author, and the email address of the author. Hey, Jan, can you can you regarding the authors, can you take a note for us to modify the description of this so that it's contextual to the author itself, not the contact?
You mean especially for the metadata authors that we,
Yeah, let's see if we
especially
can.
at that point, note that it's for the BOM and that not for something else.
Yeah, we're reusing the object, but it looks like we're using the other description and the other example. So let's just, the name of the author, for example, is what it should be. It should read, for example.
Yep, we'll note that down.
Okay. All right. Same thing for phone. Okay. Now's the fun part. So a BOM exists to describe something, and the metadata component is essentially what the BOM actually describes. It could be a library, it could be some application or microservice, could be an entire operating system. Doesn't really matter. It is the thing that the BOM actually describes. Let's see. So that's the section we're going to be talking a little bit about. I don't think we're going to go into the individual fields yet, because I believe later on down in the spec we actually do we do the reference where we actually talk about the component object, not at metadata component, but at /component. Let's see. This is the manufacturer. This is a legacy field. This is deprecated. It does have a misspelling. So it's manufacturer. It's missing the R. So this has been deprecated. We will remove this field in a future version of the spec. Very likely in version 2.0 of the spec, it will be removed, but not before then. The manufacturer basically had the exact same kind of information that you would kind of expect it to have. So a name, address, URL, contact, all of which are optional. Again, the BOM ref, the name of the manufacturer, the address of the manufacturer. Again, this is all from schema.org. So we've got the country, region, locality, post office box number, postal code, street address. Locality, okay. All right, so that's all of the manufacturer. Okay, and this is the manufacturer. These are the contacts within the manufacturer. Again, this is an individual. So again, this is going to be the exact same fields: the name, email, phone. So all of this is the exact same data because we're pulling from the exact same objects. This is the supplier. So the supplier and the manufacturer of the BOM can be different entities. So this also describes the exact same models. But again, this is the supplier, not the manufacturer. So the name of the supplier, address, URL, contacts. So again, the exact same information here. And let's see, contacts for the manufacturer. Yep. context. Okay. The license of the bill of materials. So this is the license of the BOM document itself. And the license for the BOM is typically going to be different than the license of the components, either the primary component, that that metadata component, or the components that are included in inventory. This is going to be, in a lot of cases, this is going to not be any kind of open source license. This is, in a lot of cases, this is going to be, a license that is granting very specific permissions and under very specific conditions that the BOM can be used from one supplier to their customers, for example. But you can specify SPDX license IDs because you theoretically can have a BOM for an open source package, and that BOM could be, for example, a Creative Commons type license, right? So that use case is supported. You can specify multiple licenses. You can specify a SPDX license expression. Let's see. Okay, this is one part of the spec that is, or not part of the spec. This is one part of the, actually, yeah, Jan, this is one part of the spec that does need to be revisited in terms of documentation. There's a fair amount of these undefines in this human readable document that do not show up in the JSON, on the documentation on CycloneDX.org. So there's a fair amount of these, so we need to correct these. Okay, so this is the license object. So again, the license object can have an identifier. Again, this is going to be unique within the BOM itself. It can have an SPDX license ID. One thing that we should probably add here, Jan, is that this is actually strict validation. We actually check to make sure that, yes, it is an actual valid SPDX license ID. So we should probably expand upon this description. So if you can also take a note of that, Jan, that would be amazing.
Will do,
so
yeah.
Okay, awesome. So this is a strict validation of an SPDX license identification identifier. If it's an invalid license ID, validation of the BOM will actually fail. This is a license name. In a lot of cases, this is going to be, and we should probably correct this as well, Jan, but in a lot of cases, this is actually going to be the license from like a vendor, right? Acme Incorporated license type of thing. So it's not just if SPDX doesn't have a license, it's also a lot of the commercial license use cases will use the name field as well. This is new in 1.6, although this is one area where SPDX has kind of excelled historically, is being able to declare whether or not it was a declared license or a concluded license. Declared licenses are essentially what the authors of the component intended to do in terms of their licensing terms. Oftentimes, the declared and concluded licenses will be the same. However, there are certainly conditions where the declared and concluded licenses will be different. The concluded licenses are essentially the effective licenses that are identified after some type of analysis, whether that's automated analysis or through a legal team, through manual review, the concluded licenses are what actually the project is governed over. We also support this third type of thing, and we've supported it in CycloneDX for a while now. But you know, while the acknowledgement is either a declared or concluded licenses, we do have this concept of observed licenses, and observed licenses are essentially the evidence that we collect that then substantiates a concluded license. So we actually have all three. This is the text for the license. So if you wanted to inline like all the text for all your open source licenses, that is possible. Although the BOM will get very, very large if you do that, it is a valid use case, and a lot of the legal teams actually like that to happen. The URL to where the license file can be found. So if you don't want to include, for example, the full text, you can include, for example, the URL. That would be one way to reduce the size of that. Licensing, we're going to go to in a little bit, but this is where a lot of the commercial licensing support happens. And then we have this thing called properties, and you're going to see this throughout the spec. Properties are essentially a name value store that we can put additional data into that maybe the spec doesn't actually natively support. And we have a formal taxonomy on GitHub where organizations can register their quote unquote namespace so that they can communicate to others, you know, what these properties actually mean. So it's a kind of a way to extend CycloneDX in a pretty elementary kind of way, and do so in a way where it's going to behave the same, whether it's JSON, XML, protobuf, or some other type of serialization format that we use. Okay, these are the descriptions of what we just talked about.
Wait a second, please.
Yeah.
Could you go up to the SPDX license ID, which we just discussed? You asked me to note that this thing should state somewhere what a valid SPDX, in quotes, makes it a valid SPDX. And the thing is that we actually don't support all the SPDX licenses that are out there or defined or declared, but instead we do have a snapshot which defines our own list of allowed or valid SPDXs. So this thing is not only a string type, as you can see, but in fact it is an enum with a clear definition of allowed values, which is exactly what Steve asked me to add for the next time. So this
exactly, that's a good point.
We will expand on that.
Let's not include the enum, however. What we should do, because the interesting thing about CycloneDX is that the enum, the list that Jan mentioned, is external to the actual spec, so that we can add SPDX license identifiers independently of a CycloneDX specification version, right? So we can have the exact same, you know, like Cyclone 1.5 or 1.6, and the list of supported license IDs, as the SPDX team is the authoritative source for identifiers. We actually maintain a list that is in sync with the official list. Therefore, we kind of decouple the two things, but including them in this document, I don't think would be a good idea. Although we should definitely say that it is an enum, and we probably should include the fact that here is the URL that you can fetch the list of enum values from. That should definitely be in here.
Okay, we'll note that down.
Okay. Good call. Good call. A little bit more, I guess. This is the same text that you saw up earlier from the license acknowledgments, so declared versus included licenses. The difference here is that you're actually seeing what the definition of declared and included actually is. So declared licenses represent the initial intentions of the authors regarding licensing terms, and the concluded license are verified and confirmed. So that's really the only difference. This is also a pattern that you're going to see throughout the spec. Anytime in the specification where we have the option to attach something, whether it's attaching evidence or attaching a license or attaching something else, it uses the exact same part of the model, and therefore it's going to have the exact same properties and descriptions. So this is the first time we're encountering this, but we're going to see this just like we saw with the organization name and contacts and whatnot. You're going to see this kind of pattern throughout. So this is the first time we're encountering it. Subsequent times we'll go through it a little faster. The content type. So this is a what used to be called, for example, a MIME type. So this defaults to text/plain. Although if you want to attach a PDF or a Word document or something else, you can do that. The optional encoding, and then so the encoding, I believe, is the only encoding format we support is base64. Which is really the only applicable thing to potentially encode it. As other kind of use cases come up, we can always add this because it is an enumeration. So we've got the encoding, and then we've got the content itself. So this is the for example, if we encoded it with base64, for example, then this content would be the base64 represented value of whatever we just are attaching. This is a kind of not a warning, but some guidance, right? Because we're attaching things to the spec, there is the potential for obviously misuse. Right. So if you wanted to, anytime, just like with email, right? If you attach something to an email, well, it's possible that, somebody can send you a Word document or a PDF and it's fine. Or sometimes it might be malicious, right? It might have a virus or malware or, some other thing. So this is a kind of a warning statement saying that proactive controls such as input validation, sanitization, should be employed to prevent misuse of the attachment text. Okay.
Wait a second, please.
Yeah.
From our community, I know that there are lots of questions regarding the attachment system. And the usual, very common question is whether the encoding, which is an optional field, does have a default value, which would be base64, or whether there is no default value, meaning I could attach elements or stuff that is not encoded at all. And could you elaborate on the use cases of that, maybe?
Yeah. So the encoding does not have a default value. For anything that does have a default value, you'd actually see it here. So like content type actually does have a default value, which is text plain. So if you wanted to include like text such as, I don't know, maybe the entire text of the Apache software license, for example, and you did not want to encode it, well, you could actually just supply the actual content itself without specifying encoding and without specifying content type, because content type, defaults to text plain. and it's not encoded. So, so yeah, this does not have a default value. Theoretically, I mean, in a future version of the spec, we could have an encoding of none, and set that to the default to make it a little bit more clear. But if that's something the community wants to do, we can certainly put that into 1.7. It might be a nice thing to have. Okay, excuse me. License URL, licensing information. Oh, this is the commercial aspect. So not all licenses are open source. And it was kind of came to our attention that the SBOM use case, the need to kind of support commercial licensing was heightened with the future outlook of being able to having to share all these SBOMs across different parties in the supply chain. So because of the SBOM use case, it really amped up the need to support commercial licensing in addition to all the open source licensing that we support. So that's what this licensing does. So for example, the license name, as stated earlier, the license name could be, Acme Incorporated license, for example. We can give it some alternate identifiers. Maybe I have some internal or even some external identifiers that, people are kind of accustomed to seeing. We can specify those. We can provide who the licensor, the licensee, and the purchaser. These are either individuals or organizations. The licensor is the organization that grants a license to another individual or organization. The licensee is the individual organization for which a license was granted to. And the purchaser, the individual organization that purchased the license. So we're capturing all three of these things. A lot of the fields and whatnot really align to the, so in enterprise software asset management or IT asset management, these kind of fields and whatnot are very, very common for commercial licensing use cases. Looks like Matt had to drop. Okay. We'll go through these one at a time here. So again, this is the alternate license identifiers. This is an array of strings. That's interesting. I'm just now noticing. Oh wait, no, it's right here. Never mind. Okay, so this is an array of type string. Okay. Licensor. This is going to be either the individual or the organization. Looks like we're missing the description for the individual here. So that will be corrected in the documentation. Licensor. So this, again, this is the exact same fields that we've been seeing. So this is the name, address, URL, contact. And then of course, we're going to have the same information for the contacts as well. So again, this is the organization with all the address information from schema.org. And then let's see, organizational contacts. So this is the contact for the organization for the licensor, right? So again, this is going to be the exact same fields: name, email, phone. And then if the choice is not a organization, but it's an individual, well, then here is the fields for the specifying the individual licensor. So again, it's the same 3 fields or 4 fields, whatever it is. Okay, so this is the licensee now. So this is the individual or organization for which a license was granted to. Again, it looks like we're missing the description on that, so that will be corrected. Okay, so this is the organization part, name, address, URL, contact, address, and all the schema.org stuff. Locality, post office, street, organization, URLs, contact. Okay, so this is the contact within the organization. Again, it's the exact same fields. And then if the choice was not an organization but an individual, then again, these are the fields that you would use. Again, we'll fix that description. Let's see okay. That's the address. This is the purchaser. So this is the purchaser. So this is the last of the three big organization or individual choice objects here. Name of the contact within the organization who is the purchaser. Okay, it's exact same stuff. Purchase order. Okay. Finally, something that's different. This is the purchase order number. So this, if you are using a procurement application that is tied into like a CMDB, for example, having the purchase order is kind of vital for tracking purposes. The license types are also supported in CycloneDX. This is an array. It can be multiple, so you can actually combine, mix and match these types if they are specified. So these are the different types of license types that we support. So like an academic for educational purposes, whether or not the license is for like an embedded piece of hardware, a CAL or client access licenses. We support concurrent user licenses, or also known as the floating license. We support core points, which is basically a computer's processing capabilities. In some cases, some software is licensed for maybe 4 CPUs versus 8 CPUs types of things. There are obviously a lot of different types of metrics that software is not just core points but other types of things. So we have this catch-all for a custom metric. So it's some kind of metric that's not natively supported. We can specify that it's on a per device type of deployment or license, whether it's an eval license, whether it's a named user. For example, I might have a license that is specific to me as a person. I might have a license that is very specific to an individual computer or tablet or whatever the case is, which is a node locked license. An OEM license is really about you see a lot of this in manufacturing, for example. These types of licenses are usually delivered with hardware, and it's very specific to that particular OEM agreement. Perpetual license, this is something that you pay for once, and then you can use the software for eternity. Processor points, kind of like core points up above. This is done by processors, not cores. Subscription. So this is for software that you can use during certain time periods or up until a certain expiry date. This is very, very common for software as a service. Less common for desktop type software, although there are plenty of companies actually moving to the subscription model. User licenses, so this is like a user count, not necessarily a named user, but maybe I license software for 200 users, right? And then of course, here's another catch-all for just any other type of license that we're accounting for. There's a lot of different reasons why we are capturing the types of licensing here. One, obviously, is to help with procurement and software asset management, IT asset management. The other is actually more of a security and quality use case that we kind of go into in the authoritative guide to SBOM that was just published. There are situations where software might cease to function if a license, for example, expires, or if you go over a particular threshold, it might cease to function. In some cases, the software might actually have altered behavior. For example, if it expires, potentially because it was an evaluation license, well, maybe some of the features actually no longer function or function differently, leading to different behavior of the application. And then, of course, probably the most obvious case for including a lot of the commercial licensing support is what happens, for example, with support and being able to get updates when, for example, a license actually expires. So this is why we're tracking the last renewal and the expiration dates in CycloneDX as well. So this is the time when the last renewal took place. This is a date. All of the date fields in CycloneDX basically have the exact same statement. So we don't have the statement in the JSON schema itself. This is something that we're doing in our script to generate this documentation. But anytime we see a date field, this is basically the exact same text we're going to get for it. And this is the timestamp when the license was last renewed. If this was a new purchase, then this would also be the date that it was purchased. If the license does expire, tracking this is kind of important, again, because what happens to the software or system that the software is used in if the license actually does expire, right? You can lead to denial of service of that particular software, to different types of behaviors, to the inability to get support or updates for that software, etc. So expiring dates are kind of important. Again, this, you're going to see properties, like I mentioned earlier, you're going to see properties throughout the specification. This is another part of the spec that we support properties, which is those name value pairs that you can use to extend CycloneDX in a fairly generic way. Okay, let's see. Let's see, like metadata. Okay, so this was metadata. Okay, so this is the properties for the metadata itself. So again, if there's the metadata section, just as a kind of reiterate, this is really the section about the BOM itself. So again, if we talked about the tools that created the BOM, the manufacturer of the BOM, the supplier of the BOM, the component that the BOM describes, the authors of the BOM, right? If there's something that we're not capturing in that metadata section that we want to include in there, properties are a way to do that. Let's see. All right, here's the fun part. This is going to take a while too. So I don't know if we're going to finish even next week, but we'll start now. So this is the inventory of components. So this is software components. It could be a library, it could be a framework, operating system, could be a piece of hardware, device, some sort. This is really the list of inventory, right? This is the meat of the BOM itself. We're going to skim through all of the high level fields within a okay, this description is wrong. This is a copy paste there, Jan. So you want to see if we can correct that?
Could you scroll up, please, so I could note that down?
Yeah.
I see. Uh-huh.
Yeah, we need to fix this in the docs. So this is the inventory of all the components. And we're going to go into detail on all these things in a little bit, but high level, every component must have a type. This is required. This is more of a classification. It's kind of an abstract concept. It's not necessarily designed to be something concrete. So, cryptographic asset or a library or a framework, these are different types. We have the MIME type. Realistically, this probably should have been content type, but in the spec, it's called MIME type. We've got the BOM ref, which again is that unique identifier within the BOM. We've got the supplier of the component, the manufacturer of the component, who are the authors. We used to have a single author field. This has been deprecated in favor of this, but it'll stick around until version 2, when we will remove that field. But right now we've got an authors field, which is actually an array of objects. We've got the publisher. We've got coordinates. So a coordinate is basically the combination of a group name and version. So the group is usually, for commercial software, it's usually going to be specified. For open source software, there's very few ecosystems that actually use groups. The only one that I know of that a group is actually required is Java. So if you publish something to Maven Central, for example, the group ID is a requirement. If you publish something to like NPM, which is the node package manager used by JavaScript, group is not a requirement. It is an optional thing. In fact, most components in NPM do not have a group. And for most other package managers in repository systems like Python for PyPy and NuGet and all the other ones, they don't even support group. So again, Java, a little bit of JavaScript, and you'll see this in commercial software. This is more of a higher level type indicator, for example, of who kind of manufactured this thing, right? It kind of plays a little bit into the whole provenance thing. The name of the component, everything must have a name. This is required. And a version. The version is optional because sometimes the version can't be specified, especially on like file names, for example, right? You might have a name of a file, but you don't know what the version of the file is. Description of the component, the scope. The scope is an enum. We'll get to that in just a little bit. We support an array of hashes. So these are different hashing algorithms, most of which are cryptographic hashes. Licenses, again, we support copyrights. We support multiple ways to identify identity, multiple ways to assert the identity of the component. And in CycloneDX, we assert identity either with CPE, Perl, the Omnibore ID, or software heritage IDs. So these are the primary. Oh no, we got one more. We've got SWID too. So those are the 5 ways essentially that we assert the identity of a component, and we'll dive into each one of those things in a little bit. We used to have this Boolean flag. It's been deprecated, indicating whether or not the component was modified or not. Open source especially is the ultimate supply chain. So components are going to be modified, renamed, redistributed, on and on and on and on. So this was kind of a way to do that. A better way to do that is through the use of something we call pedigree. This is the idea of, what is the DNA that really makes up the component, right? And how does my altered version deviate from the thing that I modified it from, right? If I have a component and I forked it, well, what modifications have I made to that fork? Why have I made it? For example, have I provided any kind of enhancements or bug fixes? Maybe I fixed the CVE or vulnerability. You can actually describe all of that in the pedigree. So that's a much more richer way to represent how something was modified rather than just a Boolean indicator. External references. External references are also, you're going to see this throughout the specification as well. External references are a way for us to, they do a couple different things. They provide a reference to external systems where we can get information about that particular thing, but they also provide a way for us to establish relationships in the same BOM or even across other BOMs. So we've got, I think, 40 plus external references, all of which are also relationships. So it's one of the things that kind of makes CycloneDX unique. You can have components within a component, which is a very, very common use case. For example, you think of, for example, like an instrument cluster in a automobile, right? You have a dashboard in an automobile, and within the dashboard assembly, you'll have like an instrument cluster assembly, which is your speedometer, your tachometer, maybe some other stuff. And then within inside your speedometer component, you might also include maybe some plexiglass, some LEDs, those types of things, some paint. So that whole kind of notion of an exploded component assembly on a diagram is essentially what we support in CycloneDX. So this applies not only to physical things, but it also applies to software as well. This is a way to say that this component includes these other things, right? It's embedded within this other thing. In the case of software, there's two really, really common use cases for embedding this type of thing. In Java, they have this concept called Uber jars or fat jars, where a jar is just it's just a container of Java stuff, compiled Java stuff. And it's possible that you can then include third-party dependencies in the jar itself, right? So your first-party code is kind of mixed with that third-party code into one distributable. So that's a case where the component that you built now includes all these other components as well. The other case that's very, very common is for in C, for example, you might have statically linked libraries. And in C, you can either dynamically link libraries, which is how most dependency ecosystems kind of work, or you can statically link them, which basically means I'm going to copy that functionality from that library and include it, embed it, into that thing that you're actually creating. So that concept of component assemblies applies to both hardware and software in the case of CycloneDX. We support evidence. There's a big section on evidence. We support release notes. We're going to be talking about that. Model cards. This is for machine learning and AI. We're going to be talking a lot about that. We support data. These are data components. So that's actually one of the component types up here. Where is it at? Component type, which is required. We've got component types for machine learning, and we've got component types for data. Data can be anything from configuration to source code to other things, data sets, for example, from model cards. New in CycloneDX 1.6 is support for cryptography. So we've got an entire section within components to specify all the cryptographic properties of those things. Properties again. Also new in 1.6 is this thing called tags, which is kind of a way that a lot of the package ecosystems are starting to describe what the thing actually does. So for example, in some ecosystems, you'll see tags, for example, for maybe this is a JSON parser, or maybe it's a persistence library, or maybe it's a machine learning model on Hugging Face, and it does, text to speech or image generation or something like that. Well, these tags can be used for, describing the, grouping the capabilities to categorize these types of components. So with that, we are 1 minute, and we are going to be ending at this location, which is going to, so next week we'll basically drill down into what does the component actually include, which is going to be a fairly lengthy kind of discussion. It might take us a few sessions just to go through the component, but it'll be great because there's a lot of information to kind of cover, because CycloneDX just does a ton of things. So with that, I will stop talking, have a drink of water, and wish everyone a good day. Was there any concluding things that people wanted to mention?
Thanks for walking us through it.
Yeah, absolutely.
Steve, this is Samina. There is a lot that you're going through. It was excellent. Would you and the committee like to consider to make the meetings periodically 90 minutes to give you enough time to drill down through some of these very detailed areas that you're about to enter?
Possibly. I'll have to look at my calendar. Alyssa, we can talk about that as well.
Yeah, I don't think that would work for, yeah.
Okay. All right. Yeah, it's hard enough for me to get 1 hour, let alone 90 on a weekly.
No, that's fine. You've got a lot of time over the next 2 months to cover what we're doing. Just wanted to throw it out there.
Yeah. I'll try to get through as much as I can, as fast as I can. But I also don't want to skip things that would kind of be, important, I guess, to understand. But we'll get through it. All right, thank you, everyone. I appreciate you being here, and I look forward to catching up with you all next time. Cheers.
Thank you for this.
Thank you.